So in this video, we'll look at projection of vector u onto vector v. So the projection of vector u onto vector v is given by this formula. So projection of vector u onto vector v, or we can write in the form of projection of v vector u. So this is we write a small capital of vector v, which is equals to the dot product of vector u and vector v divide by the magnitude of vector v squared. So don't forget to put square here. And then multiply, and this value we multiply with the vector v. So if you look at example 4, find the projection of vector A onto vector B. So you can see we can write in the form of projection of vector A onto vector B. So what does this do? What does the solution for this question is? First, we try to find the dot product. So you can see that dot product of vector A and vector B. Next, we can find the magnitude of vector B. And then finally, from this output, we will multiply this value with the vector B. You can see that from this formula, vector A only appears once. So after that, we just substitute this value into the formula. And then don't forget to put power of 2, this square here. So after that, we just multiply into this bracket. So if we look at this exercise, given vector A and vector B, find the projection of vector B onto vector A. So here is projection of vector B onto vector A. So basically what we do is we start with by changing this vector A and vector B into coordinate form. So let's say A, the coordinate of A will be 3, -4, and 1. Whereas the coordinate for vector B, so this is vector A, here is the vector B, is equals to -2, 1, and 5. So don't forget the formula will be projection of vector B onto vector A. So the formula will be vector B, dot product of vector B and vector A, divide by the magnitude of vector A. Don't forget we have square here. And multiply by the vector A. So you can see that vector B only appears 1. So now I can find this value separately. Let's say I start with dot product of vector B and vector A. So what is vector B? Which is -2, 1, and 5. Then multiply or product with vector A is 3, -4, and 1. So again here, multiply -2 times 3 plus 1 times -4 plus 5 times +1. So here we should have -6 plus 4 plus 5. So 9 minus 6 will be +3. Next is the magnitude of vector A. So the magnitude of vector A will be square root of. So the vector A is 3 squared plus -4 squared plus 1 squared. So from here we have square root of 9 plus 16 plus 1, which is square root of 26. So now we have all the value. So next, we can substitute into the formula. Projection of vector B onto vector A. So the formula will be the dot product of B and A, vector B and vector A, which is 3, over the magnitude of A. So which is square root of 26, but don't forget we have square here, power of 2. Multiply with the vector A. So our vector A, either you want to find write in the coordinate form, or you can write into this form, 3i minus 4j, and then plus k. So this is the vector A. So from this part, we have 3 over 26, because square root, when we square, what we have here is 26. So here is 3i minus 4j plus k. If we try to multiply into this bracket, we should have 9 over 26i minus, here, suppose we can simplify, we should have 1 over 3j. So again, 1 over, is it true? 12, no, sorry, 12 over 26. Sorry, this is what, not 1 over 3. So here we should have 6 over 13j, and finally 3 over 26k. So here is the answer for the projection of vector B onto vector A.